Michio Kaku, a prominent and accomplished physicist of our time, has provided his perspective on a groundbreaking discovery. Kaku, renowned for his exceptional contributions to physics, recently confirmed that the James Webb Space Telescope has unveiled 6 enormous galaxies, which many scientists had previously thought were impossible to exist. These findings could potentially open new dimensions in our understanding of the universe, making them both exciting and crucial to follow. Kaku is an exceptional figure in the scientific community, a physicist with both American and Japanese roots, and an expert in classical experimental physics and quantum mechanics. Unlike some more conservative scientists, Kaku is not part of that group and has embraced the incredible results of the James Webb Space Telescope mission. It is thrilling that this highly regarded scientist has chosen to speak out and reveal what can no longer be ignored in public. The enthusiasm, even a touch of amusement, is evident in his remarks regarding the discovery made by the telescope. He expressed that this has become a key highlight that piques his curiosity. Come along with us as we investigate the repercussions that Michio Kaku's reflections on the discovery of these 6 massive galaxies have. Throughout his career as a scientist, Kaku has consistently been open to new theories. He acknowledges that the equations of relativity by Einstein and Newton's laws are insufficient for capturing the full complexity of the cosmos. Kaku recognizes that the James Webb Space Telescope's discoveries have the potential to greatly enrich the scientific field. Even though many of his peers have been unable to embrace this view, this has sparked concern and anxiety among proponents of the Big Bang theory and some supporters of quantum mechanics. However, Michio Kaku only finds this amusing. 6 massive galaxies from the beginning of the universe have been discovered, thanks to the JWST. Despite having formed between 200 and 700 million years after the Big Bang, these galaxies contain more stars than the Milky Way. These remarkable galaxies have been appropriately dubbed universe breakers by the astronomers who made this discovery. Since confirming their existence would completely alter our understanding of the universe, something here doesn't align with what we thought we knew. The Big Bang theory tells us that the cosmos was in a chaotic state right after the initial explosion. Solid things didn't form for hundreds of thousands of years. It took millions of years for them to get enough density and start putting out light. The formation of complex structures like galaxies was assumed to happen much later. However, given that some of the newly discovered galaxies are even larger than the Milky Way and have a high luminosity, it is likely that they were rapidly forming new stars as opposed to our own galaxy, which only occasionally does so. When the first galaxies appeared is still a mystery to scientists. So far, the only certainty is that initially there may have been only isolated stars or small groups of stars, which later combined to form larger accumulations, ultimately resulting in the development of dwarf galaxies. These small galaxies collided with one another, gradually growing larger. Large, organized galaxies couldn't have been present at such a young stage, according to previous theories. This raises the question of whether the universe is much older than we thought, or whether complex galactic structures formed earlier than expected. Conservative science still faces difficulties reconciling this model, making it difficult for them to accept this scenario. This discovery is met with resistance in some areas of physics, where the precision of age calculations is questioned. Kaku is aware of these challenges and commented that many outdated and incorrect theories persist, due to the prestige of certain scientists. These theories were only disproven when critical experiments revealed their flaws. As Kaku puts it, the core of scientific progress, particularly in physics, relies on experimentalists who ensure theorists remain accountable. In reality, we know very little about the true origins of the universe. On the basis of observations, demonstrating that the universe was expanding, the Big Bang theory was first proposed in 1927. The hypothesis that the universe began from a single point and has been expanding ever since was based on these observations. At that time, it was difficult for people, including scientists, to conceptualize a universe that had a beginning and an end. They couldn't fathom the idea of an infinite, eternal universe. Even today, scientists continue to grapple with fully understanding this concept. However, considering these possibilities is essential. Once more, these new findings clash with the foundation that researchers have relied on for decades based on the Big Bang theory, but science has shown time and time again that rethinking old ideas and being open to new ideas are essential to scientific progress. The validation of theories through observation is an ongoing process. When Einstein was a child, it was believed that stars and planets were fixed in place in the universe, occupying definite positions. However, we now understand that everything in the cosmos is in motion. Stars move within galaxies at speeds of hundreds of kilometers per second, planets orbit stars, and galaxies themselves move quickly through space. Their final outcome is still a mystery. Today, scientists are coming to terms with embracing uncomfortable truths, realizing that theories are merely hypotheses, not immutable facts, until they are rigorously tested and substantiated by precise observations. The Big Bang theory emerged from the realization that galaxies are moving away from one another with a speed proportional to their distance from Earth. This observation, known as Hubble's law, suggested that the universe was expanding. This theory was supported by additional evidence from elements like cosmic background radiation and the redshift of light from faraway galaxies. However, it is essential to keep in mind that prior to new observations or technological advancements, leading to a more precise understanding, those who held the views that the sun revolves around the Earth and that the Earth was flat also had evidence to back up their claims. We find ourselves in a similar situation today. Scientists expected the new James Webb Space Telescope to confirm the assumptions of the Big Bang theory, but instead, it revealed 6 galaxies that defied expectations. We are reminded by this that science is always changing, and scientists need to be open to new discoveries and reevaluate their theories whenever new evidence comes to light. Redshift is used by scientists to measure various cosmic quantities. The term redshift, which also goes by the name Doppler effect, refers to the color shift that occurs when the light source moves away from the observer. Imagine standing still and hearing the sound of a car approaching you. As the car gets closer, the sound becomes louder. However, when the car moves away, the sound changes. Similarly, when a light source like a star moves relative to us, the light shifts toward the blue end of the spectrum as it approaches and toward the red end as it moves away. This phenomenon is known as redshift. Physicists use redshift values to calculate velocities and distances in cosmic measurements. However, it is essential to acknowledge that even minor measurement errors can have significant effects. Now that the previous measurement methods have been reviewed, it will be interesting to see what researchers conclude from the new data. As for the latest revelations about our universe, we must consider whether they are truly based on redshift errors, or if some scientists are simply refusing to accept the facts. The research's data and methods must be carefully re-examined and thoroughly analyzed in response to this question. Thank you for watching this video. As always, we encourage you to post your thoughts or questions in the comment section. If you like the video, don't forget to hit the like button, share it to reach a wider audience, and subscribe to the channel so you don't miss future content. Thanks again for watching, and we'll see you in the next one. The recent advancements and findings in space research remind us that the scientific community must remain flexible and adaptive to change. New discoveries can often challenge deeply held beliefs and established theories. This ongoing process of re-evaluation is demonstrated by the remarkable discovery of the 6 massive galaxies made by the James Webb Space Telescope. As we continue to study the cosmos, we should keep in mind that the universe might be far more intricate and mysterious than we previously understood. The galaxies uncovered by the telescope, which exist much earlier than traditional models would suggest, may require an overhaul of many of the concepts we have long taken for granted. This development is not just an anomaly, rather it is a turning point in the development of science. Scientists, including Kaku, emphasize that our understanding of the universe is incomplete, and each new discovery only adds layers to the ever-evolving narrative of cosmic exploration. The resistance that some in the scientific community express toward these new findings is not uncommon in the history of science. Paradigm shifts often face skepticism from those invested in the old models. However, as Kaku points out, history is filled with examples where once accepted theories were eventually replaced or modified after groundbreaking experiments and observations. It is this openness to change and discovery that has propelled human knowledge forward and allowed us to make sense of the universe in ever more profound ways. The significance of these new findings is not just in their CE. The rate at which galaxies and stars form is remarkable. As more data becomes available, we may be on the verge of a new era in cosmology, one that challenges the very foundations of what we thought we knew about the universe's history. Kaku's perspective on the situation is important because he is willing to accept new evidence and ideas, even if they are disruptive. His recognition of the significance of the discoveries made by the James Webb Space Telescope is indicative of a larger shift in scientific attitudes toward greater flexibility and openness in the face of new information. The scientific community has long relied on empirical data and rigorous testing to form conclusions. However, as we can now see, the data can sometimes take us in unexpected directions, requiring us to reevaluate even the most fundamental assumptions. In the end, the work of scientists like Kaku is a reminder that the pursuit of knowledge is ongoing. We are always looking for new data that could change how we understand the universe. Whether it is through new telescopes, more advanced instruments, or novel theoretical frameworks, the journey to uncover the secrets of the cosmos is far from over. These recent findings will likely be just the beginning of an exciting new chapter in the field of astrophysics. Keep in mind that science is a process driven by curiosity, skepticism, and most importantly, a never-ending search for the truth as we progress on this journey of discovery. The revelations made by the James Webb Space Telescope are not just the work of a few astronomers, but part of a larger collective effort to unlock the mysteries of the universe. Each new piece of data adds to the picture, and each discovery gives us a new perspective on the universe. We should all continue to be interested in the wonders of the universe during this exciting time in space exploration. We are reminded of how much more there is to learn and discover by the questions posed by Kaku and his peers. We might notice even more shifts in our understanding of space, time, and the very nature of reality itself as new findings are discovered. The journey is only just beginning, and who knows where these new insights might take us in the future. Thank you again for following along in this exploration of the latest discoveries in space science. We encourage you to keep asking questions, keep searching for answers, and above all, keep exploring. Our understanding of the universe is still unfolding, and with every new discovery, we move a step closer to understanding the incredible complexity of the cosmos. The implications of these findings are profound, not just for our understanding of the universe, but also for the broader philosophical questions that have long occupied scientists and thinkers. Humanity has pondered the true nature and origins of the universe for centuries. The Big Bang theory has been a major part of the explanation for how the universe started, but these new discoveries challenge that view. The James Webb Space Telescope's discovery of galaxies suggests that our universe may be much older and more complex than previously thought. This shift forces us to reconsider everything from the formation of galaxies to the very structure of the cosmos itself. As Michio Kaku and others in the scientific community have pointed out, it's crucial to approach these new findings with an open mind. Science is a process of continuous questioning, testing, and refining ideas. What we once accepted as fact may no longer hold true as we uncover new evidence. The skepticism faced by these recent revelations is part of the natural, process of scientific discovery, and while it can be uncomfortable, it's an essential part of pushing the boundaries of knowledge. The excitement, however, is palpable among those who are eager to explore these anomalies and their implications for our understanding of the universe's early stages. It's important to note that existing models of cosmic evolution are severely hampered by the discovery of galaxies that formed so early in the universe. As we continue to grapple with these groundbreaking discoveries, the implications extend far beyond just galaxy formation. The discovery of these 6 massive galaxies, which are much older than previously thought, has the potential to fundamentally alter our understanding of the very fabric of the universe.